We are with 6.08. What we're going to look at today are more of the same situations and simulations that we looked at previously, but we're going to try and refine our answers to make more specific recommendations based on the results that we get. So for example, if you were to witness someone flipping a coin 5 times and getting 5 straight heads, can you back up why it is that you are not confident that that will happen often, right? And so what we're going to do is we're going to look at some of the data that we generate from the sample trials and simulations that we do and kind of articulate what certain results mean. So we're going to go back to this question where a police officer observes 400 cars go by in an hour, and he notes that 65% of the drivers are wearing seatbelts. So the police officer wants to know, little typo there, wants to know if it is plausible that the actual proportion of drivers wearing seatbelts could really be 70%. Design a simulation that the police officer could use to test this hypothesis. Right? So what we're thinking about here is if the true proportion were 70%, how often when I select 400 of them, would I get 65% that are wearing seatbelts? Right? So what can I do? How can I simulate this situation? So what you should do right now is pause the video and draw up a simulation that you could conduct. And you might want to run a couple trials for yourself so that you can just kind of get the hang of what you would be doing. As a fair hint, you should probably use a random number generator. All right, so what can you do? Well, you want to simulate 400 cars driving by and whether a person in that car, the driver in that car, is wearing a seatbelt. And the true proportion, you're going to say, let's assume it's 70%. So how could you simulate one car driving by? Well, what you could do is you could select a random integer between 1 and 10. All right? Now, if your number is 1 through 7, then you conclude wearing seatbelt. Wearing seatbelt. If, however, it is 8 through 10, then they were not wearing their seatbelt. Okay? And you might say, okay, well, this represents one car going by. But if you go back to your simulation guidelines, remember, we have to use a simulation that is the same as this particular situation. So we have to look at 400 cars going by, right? If a police officer observes 400 cars, we have to run our simulation with 400 cars so that we can test out how many times we're getting 65% of them wearing a seatbelt. So we don't want to select 400 random integers by pressing enter 400 times. So a way that we can do this is we can have our calculator actually print out 400 random integers. So we could do random int from 1 through 10 and have it select 400 of them. And then what we will get is a string of 400 numbers, okay? 1 through 10. All the ones that are 1 through 7 will count as wearing a seatbelt, and all the ones that are not will count as not wearing a seatbelt. And then based on this string of numbers, we can compute how many of them are wearing seatbelts, right? What percent are wearing seatbelts? So for each one of these, we can compute the percentage that is wearing a belt, right? Okay, now think about it this way. If we just do this one time, does that tell us anything? No, right? Because if you do this one time, maybe you do get 70%. Maybe you get 62%. Maybe you get 25%, right? Maybe you get 25%. If you get 25%, are you going to be really confident that you get 25% of them wearing seatbelts again? No. Probably not. So how many times should we run this simulation? Well, probably want to run it as many times as possible, right? The more times we run it, the closer we're going to get to the sample mean. So what we could do is we could run this simulation maybe 100 times. Okay? And so if you ran the simulation 100 times, you would get some data that looks kind of like this. So look down here, and what we'll notice, each of these dots would represent me running a simulation, and this dot, for example, right here, this represents me running a simulation where I got 70%, or 0.7 being the proportion of people who were wearing seatbelts. Right? And for example, this dot over here represents me running this simulation and getting, let's say that's maybe 61% of them wearing seatbelts. So, I've run this a fair amount of times. Maybe I run, 100 simulations, and I get something that, looks like this, where obviously the majority of my simulations are going to be in the 70% range. And what I can do is I can take a look at my 65 percenters. Okay? And I can say, okay, how likely would it be for me to run, to take a sample of 400 cars when the true mean is 70% and actually get 65%? Well, what is the probability that I would get 65%? We can actually take a look at what the probability of getting 65% is by seeing how many did we get in our sample, in our trial, how many in our trial ended up being 65% divided by the total number in our trial. So in this situation, there are 40 trials here. There's 40 different trials, and so the probability of getting 0.65 ends up being 2 out of 40, or 1 out of 20, which is 0.05. So what this means, of course, is that based on our simulation, we'd expect to get 65% of the drivers wearing seatbelts a very small amount of the time if the true mean were 70%. And of course, we know, a 5% probability is not a very high probability. So we might say, look, you know what? I don't think the true number of people who wear seatbelts is going to be anywhere near 70% because I ran this simulation and I found that I would only get a 65% return 1 out of 20 times. And so I would have to say that I'm guessing the true mean is probably a little lower than 70%. So now let's go ahead and take this idea and we'll look at some sample data and draw some conclusions about whether or not we would expect to get certain results given certain situations. So a Gallup poll, which is a national polling service, conducted in July 2014, asked a random sample of 500 U.S. adults, how much attention do you pay to the nutritional information that is printed on restaurant menus or posted in restaurants, including calories and sugar and fat content? The results came back and said that 43% claimed they pay some attention. So let's say that you want to test whether or not this result is likely if the true percentage is 50%. Design a simulation to test your hypothesis. So the first thing you want to do, go ahead and design a simulation. Make sure that your simulation follows all the guidelines that we discussed previously, and then we'll go ahead and take a look at some sample data. So if you were to design a simulation here, what you're going to want to do is think about how could I represent one adult picking that they pay attention, they pay some attention. Well, if the true percentage is 50%, you could flip a coin, right? Because a coin has 50% chance of being heads or tails, and you could assign either heads or tails to paying some attention. But then you would have to flip 500 coins because you have 500 adults. So it might be much easier to use a random number generator, select a random number between 1 and 2, and pick 500 of them. And then count up the number that said 1 and say, okay, that's the number that paid some attention. And that would be one trial, right? But if you ran that one trial and say you got that 75% of the adults said that they were paying some attention, well, that's because you ran one trial. Anything can happen in one trial. But the more trials you run, the better your data will be, and you'll get a better idea of how likely it is for 43% to say they pay some attention. So let's go ahead and take a look at some data of a situation just like this. Right, so here's data from simulation that was run where there were two options, right? A 1 or a 2. So two numbers. Pick a number between 1 and 2. And 1 represents that they pay some attention, and answer choice 2 was that they pay no attention. Okay? And this was the proportion that said that they paid some attention, right? So for example, if I look at this dot here, I look at this dot right here, that would represent one of these trial runs in which the sample proportion was, it looks like 50%, right? Very close to 50%. Right? And what we did here is we ran 1,000 of them. So there are 1,000 of these trial runs. And the proportion for each trial run is marked by a dot. And so the question is, based on this simulation, what do you think about this result? Is this result something that you would expect to get if the true percentage of adults that pay attention, that pay some attention, is 50%? So have your answer written out. Make sure that you're using mathematical language and referring to the sample data that you collected. It will be important that you have tried this out because in class on Friday we're going to have a very short quiz that will relate to this problem, and so it'll be obviously helpful if you have already thought about it and tried it out.